Our next speaker is Dave Johnson from the ONS, and Dave will speak about better data science for better decisions.
There we go. Thank you very much. Good afternoon, everybody. My name is David Johnson. I'm a Deputy Director at the Data Science Campus, which is a government R&D hub for artificial intelligence and data science based in glamorous Newport, South Wales. We'll be talking a little bit about that. I suppose by way of introduction, while Dan was working away in engineering, and that led to a career path in this area, I at the same time was working away on Reformation and the Enlightenment history. So you can see how that's directly applicable to a career in machine learning. I've been working in machine learning probably for about 15 years now. Initially I was part of the leadership team that set up Google's European headquarters in Dublin, and I ran one of their programmatic ad networks for a couple of years before branching off and setting up my own machine learning company that focused on social media analysis, doing local event detection by mining geolocated social media photo and video uploads, passing that information on to media companies to help them detect breaking news stories and provide content for what they were doing. Then back in 2016, I left the dark side and started a career in public service, coming across to the Office for National Statistics to set up the Data Science Campus. So one of the things that I've been told by my team when I'm getting up and talking is they say, Dave, you're not doing a TED Talk. So don't leave it to the very end to tell everybody what it is that you're talking about. So this is my last slide. Technology is easy, culture is hard. That's what I'm going to be spending the next half an hour or so talking about. Little bit of background about the Office for National Statistics. So folks coming from a maths and stats background hopefully know us. We are the UK's National Statistics Institute. We are part of government, but we're a neutral body. We don't report into a government minister. We are a neutral provider of statistics and analysis to the rest of government to help everybody in government make the decisions that they need. We provide all the data and the information around how the economy is doing. We provide information on population statistics, on health statistics, education statistics, etc. What the general population is probably most familiar with us is the census, which we deliver once every 10 years, and we're about three and a half years away from that now. Dan mentioned an external review, the Bean Review, that took place into the ONS around about sort of 2015 into 2016. It was delivered. And Sir Charles Bean, who's part of LSE, but he's also involved with the Bank of England, gave ONS a bit of a kicking. He said ONS is very good at producing statistics using survey data, really good at producing statistics on a quarterly basis, maybe a monthly basis, with the census once every 10 years. What we weren't good at was tapping into all the available sources of data that were around us. And what we weren't good at doing was providing things in a more timely manner. Okay, the economy doesn't move on a quarterly basis. Government doesn't make decisions on a quarterly basis. Government needs to make decisions in an almost real-time basis, so we needed to get better at providing analysis and data on a much faster basis. So one of the recommendations that he had was that we should set up a research hub into new data. And he originally called it a data hub. When we went to set it up in May of 2016, we called it the Data Science Campus. And essentially its purpose was to sit down and analyze new forms of data and make recommendations out not just to ONS but to government as a whole as to how to use this data. We put this slide up here to show how fast things move. For anybody that's worked with the public sector, things move very, very slowly. We went from 0 to 100 in the case of 6 months. We got our first bums on seats, our first research projects underway, our first collaborations with external universities and partners and industry. And I think that's going to be a theme that I'm going to come back to. We wouldn't have been able to do any of this if from day one we hadn't collaborated with industry partners and academia partners to help jumpstart us or so. At the moment, we're about 55 to 60 staff. The majority of those are data scientists or analysts. We have a smattering of DevOps folks, research software engineers, and others. And then I look after a range of training and development programs for wider government. And again, we'll talk a little bit more about that later. What do we do in the campus? Well, as I said, the primary focus is to understand new forms of data from a wide variety of sources. We typically undertake short research projects, maybe 6 months in duration, maybe a little longer. So we're this blend between a traditional academic environment where you might go for a 24-month to a 36-month research project and a more commercial setting where everything is permanent beta and release as it happens or so. So we're trying to strike this medium in between. We tend to do work on behalf of other government departments or other parts of ONS. Somebody will say, hey, here's an interesting challenge, can you take a look at it? And we will see if there's a machine learning or a data science or an AI, and again I agree with Dan on the phraseology around AI, if there is a data science application that can help solve some of the challenges. We don't do this in isolation. We'll take a sort of a Horizon 2020 type approach where we will split the project up into a number of work packages and engage with industry or academic partners, each speaking to their own expertise. And we do it primarily not as a consultancy group, but if we're going to learn something new from it, that we can then make a recommendation out to the rest of government, hey, you should use this or you should stay well away from it. So what do we mean by data science in government? Just as Dan is skeptical about the phrase AI, I have a skepticism around the phrase data science, even though it's the area that I work in. Why? Because there's no hard and fast definition for what is and isn't data science. You put 3 data scientists in a room and 2 of them will gang up on the third over what it is and isn't. And if anybody has seen conversations between Drew Conway and Hadley Wickham from our Tidyverse, you'll know even the 2 of them can't agree on what it is. But this is Drew Conway's diagram. Hopefully most people in the room are familiar with it. Across UK government as a whole, there's probably about 600 folks that would consider themselves to be pure dedicated data scientists or data scientists in their job title, the majority of whom come from the maths and stats side of the house. There's a more limited number coming from a pure comp sci side of things, and then from the domain expertise, basically folks coming from microbiology or genetics or astrophysics or something that has a high degree of stats usage in it, but they're not a formal statistician. The remainder would come from there. Beyond that, we have a wider community of about 1,600 to 1,800 folks that are data science curious, or basically it's not their primary function, but they're using machine learning and data science techniques in their day-to-day job, be they economists, statisticians, operational researchers, etc. When you go out and you try and get a definition of data science, it's everybody has their own opinion of what it might be. This one came up in a Twitter conversation between Drew and Hadley Wickham, and I think it says more about the value of Venn diagrams than it does about the value of what is or isn't data science. So what we try and do is stay away from a hard and fast definition, and we try and look at specific worked examples, show by doing. We'll talk a little bit about that as we go on. One of the first things that I want to say when we have a conversation in government about data science is analytics within a public sector environment, just like analytics in general, is nothing new. As long as there have been large volumes of data, people have been analysing them to try and get interesting insights. What we have here is a picture from 1939 from London Underground, what became Transport for London, trying to do an analysis to optimise train routes. Okay? So what they're doing here is they're manually sorting, to begin with, 4 million ticket stubs for journeys from station A to station B. The sorting alone took close to a week. The analysis took 6 months to basically optimize which were the most popular routes. Okay, so that's 4 million journeys. Today on the tube, there's over 5 million journeys every single day. And the amount of routes and station interchanges have increased exponentially compared to 1939. There's new lines, there's new interchanges, so the volume has increased, and the type of routes that people can take have increased dramatically, to the point that it's not just enough to get an idea of a start location and an end location to understand congestion on popular routes on the line. It's all about those important interchanges. So if you're going and using your Oyster card or your contactless card, all it's telling Transport for London is where you got on and where you got off. That's not telling you where the congestion points are. So when Transport for London went out about a year and a half, 2 years ago to do a similar exercise to optimise routes, they wanted to find what was an available data source that they could use. So what they decided to do was, well, everybody has a mobile phone in their pocket. Can we tap into that? So across the entire network, they put in every single station, on every single platform, dummy Wi-Fi hotspots. The idea being that these did not actually connect to the internet, but if you have your phone data switched on to connect automatically to a Wi-Fi network, when you stepped onto the platform, it sent a ping out to the Wi-Fi hotspot and it said you're here. When you got on the train and got off at another tube stop, it would register again. So it could create a pattern of where you were moving through each of the individual train stations. Now, why do we show this slide? It's not just about showing the tapping into new forms of data. It's also about public consent. Okay? So think about this. You're automatically harvesting the data of every single passenger on the tube that has their phone switched on. So what did TfL do? They put posters up all around the tube stations saying, hey, we're conducting this exercise across our network on this day to this day. If you don't want to take part, switch your phone data off. So there's an open question here. Is that enough? One of the big questions that we face in government is explicit versus implicit consent. So is it just enough to say to somebody, hey, you can opt out if you want by switching off this data? Do people read it? Do they see it? How is the data going to be used? Now, the link to particular websites where you could go in and see how the data was being used, how it was stored, how it was being aggregated, anonymized, all of these things. So there was public information there, but was it enough? And that's an open question. They published all the results of this. This was very interesting to data geeks and others. This is one of the first data pulls that they published showing journeys from Waterloo to King's Cross over the period that they analysed. Up at the top left, you'll see the most popular routes. At the bottom right, you'll see the least popular routes. So, for those of you who know London, Waterloo to King's Cross, Oxford Circus, pretty much the standard way to go. 0.1% of Muppets down here travelled via London Bridge and Bank and Liverpool Street and King's Cross. When I first started using this slide, I actually went and took this journey. And instead of taking about 12 minutes, 13 minutes from top to bottom, this took about an hour and a half. So we're trying to theorise, is this drunk people? Is this lost tourists? Is it closures? What's going on there? So one of the things that we have to think about in the public sector is, once we gather the data, how are we informing people how it's being used? How are we sharing the results of this data? Why would we use data science in government? Government has vast quantities of data. We're sitting on it. We are reliant too much on manual collation of data, accessing survey data, admin data. There's a constant drive for us to be able to provide the best services possible to the public at the lowest cost to the public purse. So there's a huge operational efficiency question here. Everything for me comes down to the NHS question. If there's a finite amount of resources in government, why should anything be funded instead of a nurse in the NHS? Why should a particular project get money instead of a number of police officers or teachers? You've got a finite pool of money and you're having to balance all of this. So there's a constant drive to improve operational efficiencies or get more insights from things that we already have to help us make better decisions. This is John Manzoni, the Chief Executive of the UK Civil Service, effectively the CEO of the Civil Service. And he's been leading a drive to being able to tap more into the existing data we have to provide better insights for government as a whole, to help policymakers, to help improve services, to help drive operational efficiencies. So when we were starting to look at rolling out data science in a more methodical way across government as a whole, one of the things that we were in our mind was that implicit consent versus explicit consent. What are the public concerns around government accessing data in this way, using data in this way? So, being a survey organisation, we did what any survey organisation would do. We went out and worked with Ipsos Mori to conduct a survey of the public and find what were their concerns around government using, and at the time it was data science, but this can be mapped onto AI, machine learning, wider use of services in that area. And in general, the public are comfortable with government using data science approaches, using machine learning, if you can show there's a clear benefit to the public, if the risk of not improving services through this way was greater, and if there's transparency about how the data is being used to affect the lives of the individual citizen or so. And so we keep this in our mind at all stages. So I want to talk about some of the approaches that we've been doing in different government departments, how we've been rolling this out, how we've been using it. And I'll start with a pretty easy one here for folks to understand. Google flu trends. Google Flu Trends didn't work. One of the reasons why Google Flu Trends didn't work is because it was harvesting active information. People going out and searching for flu in particular locations. And as more people started talking about flu, more people would do searches for flu. So again, there was too much noise there, and it was difficult to actually drill down and see the value underneath. But that doesn't mean that public data like that isn't worth mining. The Food Standards Agency wanted to see, could they replicate and improve on Google Flu Trend methodology for a particular source of data. Norovirus, the winter vomiting bug. Has anybody here ever had it? Yeah, it feels like you're dying. It's one of the most horrific things you could ever go through. You just lose control at both ends. The trouble with norovirus is it remains contagious after you stop exhibiting symptoms. One of the predominant ways of getting it is people not washing their hands after using the bathroom. And then going into places like restaurants, or people in restaurants and food preparation areas who haven't washed their hands, contaminating the food products that are passed on to you. So one of the things that the Food Standards Agency wants to do is, it's really important if you see that there's a norovirus outbreak, how do you get messages out to the public to warn them, hey, it's in your area, take extra care. Hey, if you think you're contagious, don't go out for 2 days after you stop vomiting. Don't spread and don't contaminate. So predicting or identifying viral outbreaks as early as possible is really important. So one of the things they thought they would do is, can you use social media data to identify where outbreaks are happening? And they thought here, unlike Google Flu Trends, maybe if they did passive harvesting of data rather than searching for active trends, would that data be useful? So they went out to Twitter. And what they did was they first created a model where let's identify all the types of words and keywords that people might be talking about on Twitter that would indicate that they have norovirus. Believe it or believe it not, as people are sitting on their toilet, vomiting and other things, they pick up their phones and they tweet about it. That is the world and society we live in. Welcome to the future. It is glorious. So they went and they created a positive keyword list of things that people might talk about, but then what they had to do was create a negative keyword list to remove other words that might indicate they weren't talking about norovirus. So somebody saying vom, maybe they are talking about norovirus. Somebody saying vom, Justin Bieber, probably aren't talking about the norovirus. So they created a keyword mapping tool, and they then went out and measured over a historical period of time against Twitter in particular geolocated areas to see what sort of response rate they had. They then compared that to the hard and fast data that they had from the labs in those areas that were actually monitoring outbreaks against the same historical time. They mapped one onto the other, and they discovered that there was a strong correlation here. So the red line here is lab tests for particular areas. The blue line at the top is tweets about it. So again, it wouldn't be enough to produce an official statistical output, but it is enough to show that there's a solid model there that can indicate that there's a norovirus outbreak and allow you to alert A&E departments or get health messages out on social media or elsewhere. The team worked on it over the course of a number of weeks. It cost 20k to build out in people time or so. But the estimated value of savings by reducing sort of cross-infections or people going into work and contaminating other people is absolutely huge. And this is one of the things that we have to think about when we're in government. Okay, if we're going to dedicate time and resources to working on a particular project, we need to show a strong cost-benefit analysis. Again, it comes back to the NHS question. Why should I have an analyst, a statistician, a mathematician, a data scientist working on a particular project, hiring them in instead of giving that money to nurses at the front line? So that is using social media data to try and understand a particular healthcare situation. What other data can you get from social media? Well, one of the things that we do in ONS is we rely very heavily on survey data. So one of the things we wanted to see was, can we sense check our existing survey data or identify alternative sources of data that might eventually replace survey data? We have teams of people at every single airport and port around the country. And as you are going in and out of the country, they may come up to you with a tablet and say, excuse me, where are you traveling in the UK? Where are you going to next? This forms what we call our International Passenger Survey. And it's the main method for understanding tourist numbers coming in and out of the UK. It also contributes strongly to our understanding of overall migration numbers. Now, one of the things that we feared in the ONS was that were certain nationalities underreported in these passenger surveys? We had a feeling that Chinese nationals were underreported in the survey for a couple of reasons. One, when Chinese nationals go abroad, there's a maximum amount of currency that they can spend. They typically come to the UK to do big shopping trips. So they're very concerned that if they're talking to a government person with a clipboard about their shopping purchases and how much they spend in the UK, is that data going to get reported back to the Chinese government? So they're quite cautious about talking to government officials with clipboards. So we wanted to see, was there an alternative form of data that we could do to sense check our survey data? Now, in the campus, we decided that we wanted to create an initial trial using social media data. Geolocated social media data, seeing if somebody is uploading from one location for 50 weeks of the year and 2 weeks of the year in the UK, great. Are they a tourist? Are they coming here? This allowed us to create real-time heat maps of where people from different nationalities were going across the UK. Would this ever be used to produce an official statistical output? Absolutely not, because social media data has so many methodological flaws. For the sample size, who is using a particular social network, who has access to it, does it cover all income levels, does it cover all genders, does it cover all backgrounds or so. When you're looking at an international level, some nations might use one particular social network. Twitter, for example, isn't particularly large in Germany, whereas Instagram is. So again, what are the inherent biases there? But by doing this, it allowed us to, with a free set of data, understand, would it be interesting as a sense check for our survey data if we said got access to mobile phone data and bring in mobile phone data to show roaming patterns? And the answer was yes, it was. And we now have access to mobile phone data from 2 or 3 providers, so we can see roaming patterns. So again, it's a good test or a trial. But using social media data to sense check survey data. All of that is nice, but what are the big guns? A lot of work we do in the data science campus is focused on economic statistics. We produce a lot of the data that government uses to help plan the budget, to understand GDP, to understand how well the economy is doing. And around 2008, something big happened. The recession. For those of us who bought a house in Dublin in 2006, just before everything started to dip down, if I had had a little bit more information about and were able to predict shocks to the economy, I wouldn't have now a lovely house in the centre of Dublin that is worth 46% of what I paid for it. Understanding early indicators to shocks to the economy is almost a holy grail for government. It helps us plan, it helps us predict, it helps us put things in place that might mitigate further crashes and further recessions. It took 5 years for us to bounce back from the recession. It's estimated that if we had been able to understand and get an earlier indicator around shocks to the economy, we could have saved around £12 billion in lost value to the economy. But one of the challenges is the way we measure the economy. So we get a huge amount of data in from different sources, and we produce our estimates, we produce our recordings of and indicators of GDP, but it takes a while. We gather the data predominantly from survey data that comes in from a huge amount of companies all across the UK, and it takes anything up to a quarter for us to publish the outputs. So one of the things that we want to try and understand is this gap over here. Okay, if we're producing quarterly outputs 1 quarter after the data closes, what data could we harvest in this period that says maybe 1 minute past midnight at the start of a new quarter, we could give an early indicator of where the economy is going? So what sort of data sources would those be? There's a huge amount. Everything from taking in VAT data from HM Revenue and Customs. So that's collected almost on a daily basis. So if we're able to get VAT returns in at a very early stage, could we turn around and build a model that allows us to give early indicators of GDP? The answer is yes, we can. But when we backdate those models back to the downturn in the economic downturn, it wouldn't have produced enough of an early indicator or so. But so we've been modeling VAT data. But let's move beyond that. What are other available data sources that might make things a little bit more interesting? My eyes perked up when Dan was talking about automated ships. We have full access to ship transponder data for every ship coming in and out of the UK waters. Ships, every couple of minutes, ping out their location, their lat, long, etc., their GPS coordinates. So we've been tracking every single ship coming in and out of the UK. Why? Well, our colleagues in the Department for Transport and our colleagues in Statistics Netherlands have noticed that changes in road traffic in particular areas predict changes in GDP. So if road traffic in and out of a particular urban area increases, 1 quarter later, GDP in that area goes up or down by a similar amount depending on the increase or decrease. Okay, and this is consistent over multiple countries. So we tried it here in the UK and tried it in the Netherlands. Bottom line, you know, more people going into an area means more business, more people spending money. You know, you can do the anecdotal stuff yourself. We wanted to see if the same thing was true for shipping coming in and out of the UK. So is an increased amount of cargo traffic coming into UK ports mean that GDP will go up? So we've been tracking ship location in and out and modelling its correlation with changes in GDP. And while we were doing this, something happened in the UK. Not quite the same as the 2008 shock to the economy, but potentially. The EU exiting referendum. We'll have a better idea in the next day or two what the agreement is going to be for exiting the EU. But what happens if customs are introduced at UK ports? At the moment, the entire economy runs on just-in-time deliveries. Okay, there's no big warehouses. Stuff comes in from Europe, lands in the UK, and is on your supermarket shelves within 24 hours. So what happens if customs have to be introduced at every single UK port? What's going to be the knock-on effect to supply times, to delivery times? So this data then, we've been modelling port capacity around the UK to try and understand which ports are oversubscribed, which ports are under capacity, and could Department for Transport or Department for International Trade or Department of Maritime reroute shipping traffic to other particular parts of the UK to help compensate for this. So a lot of the work that we're doing is taking one particular data set that we haven't had access before, modelling or working on it to provide immediate economic statistics indicators, but then seeing how can this data be used elsewhere in government for other purposes. Now that's offline traffic. What about online traffic? Can you model online traffic as an early indicator of GDP? So we've been doing an awful lot of work on broadband networks across the UK and measuring spikes and increases and decreases in broadband traffic. So the UK economy is very heavily dependent, more so than other major European economies, on online shopping, okay, online commerce. So can we tie this into spikes, increase or decrease in UK broadband traffic to increase spending online, decrease spending online? So what happens when everybody's watching a football match? What happens when they stop watching a football match? What happens when Downton Abbey is on? How does this correlate with patterns of spend? So all of this is about bringing in as many data sources as possible to try and understand indicators to the economy. I talked a little bit there about the shipping. It's one thing to understand the ships that are coming in and out of the UK, but let's say we want to try and understand what's actually in the cargo of those ships coming in and out. And believe it or not, that's actually really difficult to do, to try and understand what goods are physically being brought in on any one individual ship or out, because there isn't a consistent system for measuring these. So one of the projects that we did was try to look at, and again tied in with exiting the EU plans, try to understand what's being shipped between Northern Ireland and mainland Great Britain on ferries. So here's the problem. A lorry arrives at the ferry port carrying a whole bunch of goods and gets ready to get on the ferry, and a dock worker stops and says, okay, great, what are you carrying? And the lorry driver will turn around and say to the dock worker, I'm carrying X, Y, or Z. The dock worker writes it down. And that's all there is for a cargo manifest, for a lorry bringing goods in or out from Northern Ireland to the UK. So the problem here is that it's an NLP issue, okay? It's easy enough to kind of, if we've got a mixture of text recognition that we need to digitize, or digitize stuff that's put in an iPad or a tablet or so, but there isn't a consistent nomenclature for what's going in and out on the goods. So one lorry driver might say car exhausts. Another lorry driver might say motor parts. Another lorry driver might say Toyota exhausts or Toyota parts. All of these things are put down in a free text form as completely different. So we basically built an NLP pipeline to turn around and try and automatically cluster through machine learning as many of these different things as possible to put some sense and structure onto unstructured data. One of the biggest challenges across government as a whole is unstructured data. We have so much free text that we gather, so many things. If everything was nice and neat and ones and zeros, we'd be laughing, but that's not the case. So one of the things that we try and do is build a tool that then allows other government departments to get more value from the unstructured data that they have. So we have machine learning and data science applied to new data sources to replace existing data, to get more insight and value from the existing data, to get insight in ways that you never understood you could. And why? This all feeds back into John Manzoni's idea around transformation in government, providing better value, providing better services. Data plus technology divided by data science, that's gone a little bit crazy, equals data transformation. So I want to spend a couple of minutes talking about the challenges associated with each of these. One of the biggest things that I had to get used to coming into government was I thought government was one holistic whole. It was a single organisation. It's not. Each individual government department is effectively its own corporation. They have some underlying structures that are the same, but a lot of times they don't. And they all have competing priorities. They're all competing for budget, but they all have competing priorities and ideas on how to deliver the best value for the taxpayer. One of the challenges is, as a data scientist, we want as much data as possible from as many different sources to be able to link it so that we can then apply machine learning and get interesting insights. Government is not set up to enable this. There's a pile of data over here, there's a pile of data over there. There isn't the legislative framework, and there isn't necessarily the willpower or the skills to be able to enable sharing back and forth. Even if you take a department like HMRC, Revenue and Customs, if you're a sole trader, okay, and you are submitting your tax returns, and you are owed VAT back, the system that manages how much tax you owe the government does not talk to the system that says how much money they owe you in VAT returns. So you can't write one off against the other. You have to turn around. They're two separate data sources and they're two separate technologies. So the technology is the next thing that I want to talk about that's a challenge for government. As a big organisation, each individual department goes out and has to source the appropriate technology and infrastructure to run its systems. Government tends to work with very large service providers who are geared up to be able to submit tenders for multi-year bids to provide technology. They're big, they're complicated, they're wieldy, and they go out of date very, very, very quickly. So this is a challenge for data scientists and analysts in general within government. Talking with my colleague who's the head of data science within the Department for Health, she puts it this way, and it's a bit of an exaggeration, but it'll help you understand. A data scientist in the Department for Health is trying to do their analysis on the exact same laptop that a receptionist in a hospital has, because you have a giant procurement bid that has a one-size-fits-all. Why can't the data scientist install their own equipment on it, their own, whatever packages they want of our Python, their own software? Well, think about the WannaCry ransomware that went out and did very serious damage to the health service. One of the problems that you have is a very small IT department that's trying to manage a huge amount of users that aren't tech savvy. And again, they have to have a one-size-fits-all approach to try and prevent exact systems like that. So you may have a group of super users in an area that really understand what they're doing, but the IT department isn't set up for that. So again, the civil service is very risk averse, and that applies to technology as well. The final part of it then is the people, the data scientists themselves. When I went back to the numbers there for the total number of data scientists in government, it might seem a little bit slow. One of the issues is, as with the NHS question, we cannot and should not try and compete with the private sector on salaries. Okay? So you know that coming out of a PhD with Cambridge, you can walk into Google or Facebook or Uber, particularly if you go to the US, and get six-figure salary. You should be starting on about 120K, something like that. Okay? That is certainly not the case with the public sector. Again, somebody coming out of a PhD might be coming in at around 40K. So again, there's a huge gap between the two there. And yet still people come to the public sector. Why? Well, one, and I say this coming from Google, it's not all about optimizing clicks on ads. The work that you do actually has a direct input and impact on the lives of everybody in the country. It has to. We can't afford to spend the money on you if you're not going to have a direct impact on the lives of the people around you. Access to data. Once you do get access to it, the amount of what you can do and the challenges that you can do are huge. And we're getting better at giving data scientists the data that they need. There's a sense of public service, there's a sense of the type of challenges that you can work on and giving back, and that's really important. But what we figured out is we were not going to be able to meet the needs of government with regards to machine learning, AI, data science, purely from recruitment. So my area is how do we augment that with a range of internal training and development programs to grow our own. So rather than relying on the input of recruiting PhD students and top folks from different universities, can we take folks at a different variety of levels and equip them with the skills to be operational data scientists? Not necessarily leading edge research data scientists, but operational data scientists to apply data science techniques to challenging government problems. So what have we done in this area? We have a range of programs. We have a range of programs ranging from apprenticeships, and again, my original idea of apprenticeships was it was plumbers, bricklayers, electricians. Within England and Wales, there's a range of highly skilled technical apprenticeships ranging from economics through to data analytics and data science. So we've rolled out the first apprenticeships in England and Wales, a 2-year diploma in data analytics, and we've just got approval and we're launching in a week's time a degree level apprenticeship in data science. So the idea is we take somebody straight from their A levels and over the course of 3 years train them up to be a data scientist or a junior data scientist. Now, the 2-year diploma program, we've just had our first graduates from that program, and every single person that's come out of that 2-year program has actually been employed somewhere else in government in the same job that somebody coming out with a master's in data science would go into. So it's basically hands-on practical work as an alternative to a pure research-focused academic thing, and we're quite proud of that. I have a training team, a data science faculty. I've gone out and I've recruited university lecturers in data science, advanced statistics, maths, and health sciences, and brought them in to develop a new data science curriculum for government. And again, with a focus on operational data science and machine learning. And the idea is we're creating a centralized curriculum and training program for government as a whole. So we will be able to work with statisticians, operational researchers, other government analysts, and equip them with the data science skills that they need to advance the next level in their role. We don't expect them to become full-time data scientists, but if they have access to R, Python, machine learning, NLP to do their jobs a little bit better, that will work. We've also, for existing analysts, rolled out a master's program with 3 universities around the country, and we'll be expanding that to about 6, where it's a 2-year part-time program for existing analysts to get trained up in advanced statistics or data science. But what we will also do is reach out to university partners where there's something that we don't cover or the master's program doesn't cover, but we want to do a really in-depth program. We work with the Turing Institute, we work with about 13 doctoral training centres around the country, and we'll bring in folks to do advanced master classes in, I suppose the most popular one for us at the moment is Bayesian statistics and computation, because you have a lot of analysts in government that might not have covered that when they did their PhDs, 10, 12 years ago or so. With universities, what do we do? As I said, we support about 13 or 14 doctoral training centres around the country. We co-fund PhDs. We do co-supervision of PhDs and MSc students, and we have paid placement programs into the campus at 2 or 3 locations around the country, as well as into other government departments. The Centres for Doctoral Training are an interesting one. So the responsibility for artificial intelligence in government has been taken over by the Department for Digital Culture, Media and Sport. And they have a new Office for AI, which is a shared initiative between them and BEIS, the Department for Business, Energy and Industrial Strategy. And they're really going hell for leather around it. The Office for AI is focused outwards. How do you stimulate the AI economy within the UK? And they're doing things like have a visa program for external AI experts to come in and be able to work within industry. They're developing or working with universities to develop a new industrial master's program in AI, which is sort of a conversion program for folks that haven't done data science or AI to convert and go into an industry with it. They're working on data trusts. So one of the questions earlier was, we have lots of data out there. How does the public get comfortable with how people are using it for AI or machine learning? And the answer is data trusts, which are a mixture of a legislative framework and also an infrastructure framework to be able to put data in a secure place for multiple users to find it. One of the other questions that came up was ethics. So within the Office for AI, there's a partner organization, the Institute for AI Ethics. And one of the things that they're looking at is this exact government approach to the trolley problem, okay? And that, so who is responsible? How should AI be employed ethically and fairly? Because, to Dan's point, what does AI mean in government? Is it machine learning? Is it chatbots in customer-facing roles within Department of Work and Pensions or HMRC? Or is it algorithmic decision making? And what happens when folks are actually taken out of the equation when a decision is being made? So does it really matter if AI is handling what film you watch on Netflix or what you buy on Amazon? Not really. But does it matter if it's deciding whether you're entitled to a particular welfare package? Or, you know, if you're going to have a particular penalty applied to late payment of taxes? The decisions that are made in government are real and affect people in real and consequential ways. So trying to figure out the ethics approach to this is key. So there's a lot of work being done on the ethics of algorithmic decision making. All of this has to happen in partnership. Government can't stand alone. And as Dan said, the public sector is behind the curve in this. We recognize this. Industry has been at the forefront for the applications of AI. Academia has been at the forefront for understanding the implications of AI, okay, and how it actually is going to affect people in the real world. And so at the campus, as with government as a whole, we work with a wide range of partners in industry and academia so that we're not doing anything in isolation. This helps us jumpstart things. Can we reach into sectoral and technical experts within academia? Can we reach out to folks within industry that have been working at the leading edge of this for some time and bring this together and harness those energies? So we have a wide range of programs that bring all of this in, allow us to evaluate stuff in a safe space in the campus, and then through our training development programs make recommendations out to government. We work in the campus with a range of organizations across the developing majority world to help them set up their own data science institutes. We work with the UN. So Dan, who is doing this at a global level? What is the infrastructure there? The UN Working Group on Big Data. And the UN Working Group on Big Data is trying to build out a UN global platform for data, which is a mixture of the infrastructure to host data at a global level for government statistical institutes and others to be able to access to make effective decision making for things like the Sustainable Development Goals and how do you measure these on a global level. So that is happening at a global level, but again, it's very slow and we're trying to kind of piece that together. So I told you I would show you the last slide first. Technology is easy, culture is hard. It's really easy to roll out a new technological solution, but changing people's mindsets on how to use it, equipping them with the skills to be able to use it, equipping them with the understanding of the ethical implications of how to use it, that's the hard bit. Except in government where technology is also hard. And that's my talk. Thank you very much. If anybody's interested in further information, got our webpage there, but the GitHub page. Every single tool we build is built with public money, so we make it publicly available to everybody. All of our outputs, our NLP tools, any of our deep learning neural network stuff that we've built out, it's all there on our GitHub page for anybody to use. All the repositories are there. So we're very much a fan of the open data policy as well, to Dan's point.
Thank you very much, Dave. Thanks a lot. Questions?
Are there any, when you said that the APIs are open, does that include open to the public or just within?
No, open to the public. It's public money, it's all public there. Access to individual data sets can be a little bit trickier. So the ONS has a thing called the Administrative Data Research Network, which enables academics to get access through to all ONS data sets. Sometimes you have to do it through a secure research environment, you know, depending on whether you're getting individual record level data from the census. But the data is one thing, but all our tools, it's all public on our GitHub page. One of the things that we try to do internally within government is you've got lots of different government departments working on similar tools. So we're creating a central repository, a central hub for all of government, basically any of the outputs that they have to share the tools around different government departments. We're not there yet. In the interim, ourselves and the Government Digital Service both have open public repositories on GitHub for all of our tools that we built out. It's taxpayer money that's let us build out. We have an obligation to provide it to folks afterwards.
So when did you start this data science program? You said your first cohort was...
Yeah, our first cohort of our 2-year program, I came on board in April of 2016. I'd set up the apprenticeship program by September and got the standard approved, and we had the first intake of students in October of 2016, so they've just graduated now. We're just getting ready to kick off our degree level apprenticeships now. Again, our first research outputs were done in about 6 months. We built the first project that we did was strictly data science, but we built the platform that the UK uses to measure progress against the Sustainable Development Goals. So it was more data viz and data dissemination output, and that's being used by about 15 countries globally now as well, because we open sourced it. And that was interesting for this environment because the way we got up to speed so quickly was we engaged with the private sector. So just as Valtech has been in with ONS to help us on a huge amount of areas like the address registry, what we did was I reached out to universities like with Warwick, with the data lab up at Warwick Business School. They helped us out with the geolocated tourist work. We divided in a couple of different packages to get up to speed. We also then engaged with a private sector data science company who placed a team of 3 data scientists into our campus to help us around DevOps and process engineering, because once you bring, no disrespect, academic data scientists into a commercial environment, it can be a difficult transition to kind of work to faster timescales, work in an agile delivery method as well. So one of the things that we wanted to do was work with a commercial partner so that we could set up what our internal processes were to kind of work a little bit faster. So, but we constantly revise those. Yeah. One of the things that we have to do with the campus is overcome the image of the public sector for mathematicians and statisticians. An unnamed doctoral training centre in the north of England that may or may not be Lancaster. I talked with the head of data science there about 3 years ago when we were first kicking off the campus. And he said when he was doing his PhD back in the 90s, somebody from ONS came along for the milk rounds and was talking about an exciting career in statistics in government. And he said it was the single most boring presentation he'd ever heard in his entire life, and he swore blind he would never work for the ONS. And if you're not going to work for ONS in the 90s in statistics, where are you going to work? Because, you know, Google, Facebook, Uber weren't around or so. And this is what we need to overcome. We need to show that, yes, you're not going to get paid as much, but the challenges and the impact are huge. And so one of the things that we're keen to do is, even if you're not considering a permanent career in the public sector and industry is where it's at for you, look at secondments or rotations of staff in and out. So we partner with a large number of tech companies to see, can we do secondments of staff back and forth, and can we share best practices? So industry, academic, public sector collaborations are key for any of the impact that we're trying to do. And I think Dan would probably agree with that. Yeah.
I mean, you're also a good example for someone transitioning between, you said Google, right?
Yeah.
And,
Yeah. It's in the US, there's an organization called 18F, which was, if you remember back to when President Obama was trying to roll out healthcare there. He set up a nice website where everybody could go and have a marketplace for buying and selling insurance. It fell over. It was a disaster because government wasn't set up to produce a system like that. So what he did was, he and his chief data scientist, they reached out to Google, to Facebook, to a lot of other companies and see could they second staff in to government for a 2-year period to help deploy tech effectively within government. And so this organization, 18F, it's a government body now, but it does maximum 2-year rotation from industry or academia potentially into the public sector. And I think that's the type of thing that we're going to start to see now, rather than purely reaching out to the public sector, to the private sector to deploy large IT infrastructure. Can you actually form a collaborative partnership where you're sharing resources and staff back and forth to come and see, keep some of that knowledge within the public sector? You know, I'm agnostic on the build versus buy approach, but it's certainly not cheaper internally to build. I have to say that. You know. Yep.
Okay, on that note, let's thank Dave again.
Fantastic. Thank you very much, everybody.